Ever wondered what happens when gravity takes a back seat and science takes the wheel? Welcome to the zero-gravity world. Here, the usual rules don't apply, and the extraordinary becomes the ordinary. In this boundless expanse, we conduct unique experiments that reveal the hidden secrets of fluid dynamics and crystal growth. Fluid dynamics, the study of how liquids and gases move, is a puzzle that scientists have been trying to solve for centuries. And crystal growth, a process that forms the basis of many natural and man-made structures. In the absence of gravity, these processes behave quite differently, offering us a new perspective to understand the universe. So, buckle up as we journey into this world of zero gravity, where science takes a whole new dimension. Prepare to defy the laws of gravity and delve into a world where science takes a whole new dimension. Imagine a droplet of water floating in the air, perfectly round, defying the laws we know. Welcome to Fluid Dynamics in Zero Gravity. Now let's take a journey into the realm of microgravity experiments. Picture a syringe, like the ones used in hospitals. But instead of injecting medicine, it's releasing a small droplet of fluid. This is not your everyday scene. It's a special experiment conducted in the microgravity environment of space. Now, what's fascinating is that this droplet doesn't fall or flatten out. It floats around, perfectly spherical. This is due to surface tension, a force that unites the molecules of a liquid, making it act like a stretched elastic sheet. On Earth, gravity tends to distort this perfect sphere, pulling the liquid downwards and creating the teardrop shape we're familiar with. But in space, devoid of gravity's influence, surface tension becomes the star of the show, shaping our droplet into a perfect sphere. Now let's add a twist. Imagine we introduce a tiny solid particle into this droplet. On Earth, this particle would sink to the bottom, right? But in zero gravity, it simply floats around inside the droplet, a tiny dancer on a liquid stage. This experiment is not just a spectacle. It's a key to understanding fluid dynamics in space, crucial for designing fuel systems for spacecraft, for instance. And what happens if we heat the droplet? Well, the heat causes the fluid to move in a pattern known as convection currents. On Earth, these currents rise and fall due to gravity. But in zero gravity, they move in all directions, creating a mesmerizing display of fluid motion. But remember, all this is just a glimpse into the strange and wonderful world of fluid dynamics in zero gravity. The real magic happens when scientists and researchers use these insights to solve complex problems, from designing efficient spacecraft as systems to understanding the behavior of biological fluids in our bodies when we're in space. So, the next time you see a ripple in a pond, remember there's a whole different story in the zero-gravity world. Crystals with their perfect symmetry are a marvel on Earth, but in zero gravity they reach a whole new level of perfection. Let's delve into this fascinating world of crystal growth beyond Earth. Imagine a pristine crystal, a lattice of atoms arranged in a perfect pattern. On Earth, gravity interferes with this pattern, causing irregularities in the crystal structure. However, in the weightlessness of space, crystals can grow uniformly, achieving an unprecedented level of perfection. One experiment that beautifully illustrates this is the growth of protein crystals in microgravity. Protein crystals are the building blocks of many life-saving drugs, yet they are difficult to grow on Earth due to gravity-induced defects. In the microgravity environment of space, these protein crystals can grow larger and more uniformly, which could potentially revolutionize drug development back on Earth. Another intriguing microgravity experiment involves the growth of semiconductor crystals. Semiconductors are at the heart of modern electronics, and their performance is highly dependent on the quality of the crystal structure. By growing these crystals in zero gravity, scientists have been able to produce semiconductors with fewer defects and superior electrical properties. These are just a couple of examples of how zero gravity can facilitate the growth of more perfect crystals. The implications of these experiments are immense, opening up new possibilities in fields ranging from pharmaceuticals to electronics. So, what does this mean for us Earthlings? Well, the advancements in crystal growth in microgravity could lead to the development of more effective drugs, more efficient electronics, and countless other innovations that could significantly improve our quality of life. In this sense, the study of crystal growth in space isn't just an academic exercise. It's a voyage of discovery, one that could unlock new technologies and transform our world in ways we can only begin to imagine. In the realm of zero gravity, crystals aren't just beautiful, they're a testament to the marvels of science. From enhancing medical procedures to advancing materials science, these zero-gravity experiments aren't just fascinating, they're changing our world. The insights we gain from observing fluid dynamics and crystal growth in microgravity are revolutionizing various fields on Earth. In the realm of medicine, for example, the unique behavior of fluids in zero gravity is helping us optimize drug development. By studying how drugs interact in this environment, we can devise more effective treatment strategies. In materials science, observing crystal growth in the absence of gravity is leading to breakthroughs. These experiments are helping us discover new materials and improve the properties of existing ones. This could lead to the development of more durable, efficient, and sustainable materials. But the applications don't stop there. The knowledge we're gaining is also enhancing our understanding of natural phenomena, like the formation of geological structures and weather patterns. Looking to the future, the potential is immense. As we continue to explore and experiment in zero gravity, we're opening up new avenues for scientific and technological advancement. Imagine a world where we can harness the power of zero gravity to improve life on Earth. This is the exciting frontier that microgravity experiments are leading us toward. As we unravel the mysteries of the universe, one thing is clear: the future is weightless. Now that we've taken a zero-gravity journey, it's time to come back down to Earth. We hope you enjoyed this deep dive into fluid dynamics and crystal growth, and we'd love to hear your thoughts. Perhaps you have an idea for your own microgravity experiment, or maybe you're curious about how these concepts could be applied in your daily life. Before you go, don't forget to hit the like button and subscribe to our channel for more exciting science exploration.